Gautam, good evening, Gautam. Send the link in the group, Gautam. Today, very important conic section session I am going to teach. Tell your school students also, if they can join the session, beta. Just 1 minute. Aparna, good evening, beta. Just 1 minute. Bhumika, Kritika, good evening. Okay. Arvind, good evening. Now look here, beta. We are going to study conic section. From the beginning part of the conic section, one by one we are going to study exactly what is a conic section and how you are going to get parabola, hyperbola, ellipse, all different type of conic sections. So Dipankar, good evening, Dipankar. Now look here. I'll start from the beginning section. I'll explain each and every part. I just want you to understand that you can see that two cones are there and they are just one on the other. The cones are exactly upright position and one on the other it is there. Adit, good evening, beta. Now why we are means how we are going to get a circle, a conic section means, as the name suggests, conic section is what? As the name is suggesting, conic section means cut part of a cone. In simple way, if somebody will be telling you, Saranya, good evening, beta. If somebody will be telling you, then you can say that it's nothing but cut part of a cone. How we cut a cone? By making different angle. That type of figure we are going to get. That is exactly coming under conic section. In simple way, without definition. If somebody will be trying to understand in simple way without definition what is a conic section, then you will say that, yeah, as the name is suggesting, conic section is nothing but cut part of a cone. What is it? It is exactly the cut part of a cone. Now how we can cut a cone? That is also a very important thing. Now you can see that there are 4 different type of cuttings here. If we will be exactly, and how which is exactly cutting it? A plane is exactly cutting it. Is it blur? Just wait for a minute. Rohit, good evening, beta. Good evening, Rohit. So exactly what we are going to, Kabilan, good morning, I am saying good evening. Good evening. Now look here. What we are going to do here is 2 cones we are going to take one on the other, and now if we are going to use plane, and the plane is exactly going to divide and cut the cone. So once the cutting will be making different angles, with the help of different angles cutting by the plane, we can make different figures. So first is like this cutting means it is going to form a circle. When as this you can see here, when the plane will be cutting by making some angle, it is exactly going to make a ellipse. And when like this type of cutting will be there, you see that this parabolic part is coming from the cut of the cone. It is exactly going to come as a parabola. Okay, now this is exactly coming as an hyperbola. Okay, this is exactly going to come as a hyperbola, this is going to come as a parabola, this is a circle, and this is exactly an ellipse. So 4 different figures we are going to get. Now we are going to study the in-depth portion of it. One by one we are going to understand the detailed portion of it. First we just understood one thing, that conic section is nothing but cut part of a cone. We are going to take 2 cones. See, always it is not necessary that we are going to get a circular cone only. We are just taking the cut part of a cone. We are taking the cut part of a cone. So conic section, as the name implies, the section cut off from a circular, means it is not necessary right a circular cone. So cone by a plane in various ways. So we have seen how, in which different ways they are exactly cutting. First way we have seen it, the plane is exactly dividing the region. So once the plane will be cutting like this, it is forming a circle. This is an ellipse, this is exactly a parabola, and this is exactly a hyperbola. So 4 different type of figures we are getting here. Now we are depending on the position of cuttings. Now we are going to go for the in-depth information here. So what and all in-depth information we are looking forward here, please pay attention here for case 1 and case 2 for understanding. This PDF will be available to you. Once this session will be over, this PDF will go to your group and it will go in Insta also. Okay, so now look here, we are going to study one by one this part. So if the plane passes through the vertex, so now the vertex, if we are going to allow the plane passes through the vertex line, so if it is exactly going to pass through the vertex, so one by one content related part I am going to discuss. Shreya, good evening beta. Shreya, good evening. I was just discussing the beginning part of it, Shreya. Now I started with the cone cutting beta. So now we know that 2 cones we have taken. Now first part is if the plane passes through the vertex O. So now we are allowing the plane to pass through the vertex O. We are going to allow the plane to pass through the vertex. So how many times it is going to cut like this? It is all possible contents are there. Now most important thing is this is exactly called as semi-vertical angle. This part is called as semi-vertical angle. This angle is called as semi-vertical angle. Okay, so this the center line is exactly there, and from this and this is supposed to be the height of the cone. Okay, this is supposed to be the height of the cone. From this, whatever angle till the slant part we are making, that is called as semi-vertical. So why I am using those words? Because you have already seen this parts. You have already, Anila, good evening beta. You have already know this section like height and slant height. So if you want to remember with that, it will be easy for you. Okay, so now just understand one thing, that from this part to this part, whatever angle we are taking, it is exactly called as semi-vertical angle, and we are going to denote semi-vertical angle as alpha. Till here everybody understood? Come on, quickly tell me a yes so that I can proceed further. Because there are many critical places where you may have problem. So to come out from that critical place, I just need to explain everything nicely. So today you have to keep on saying yes or no, so that wherever you will have problem, immediately stop me. I am going to explain. Conic section means once the concept will be easy, you will be able to handle any level question, but concept has to be clear. Okay, so quickly you have to just reply me that yes or no. Saranya, thank you so much. Kritika, I really want my children attendance today. Attendance in the sense means yes auntie, understood auntie, one more time repeat, like that. Be very quick and say yes or no. That yes or no, only Y and N also you will write. I'll start. Okay, so now look here. So most important thing is the first part we are taking, that we have taken 2 cone, one exactly on the other. Now first angle we are allowing a plane to cut the vertex region. So exactly the vertex point is exactly, now here also angle will be there. Now what type of angle and how they are exactly going to form? First case is real and distinct when theta will be less than alpha. Now what is theta forming? Where is theta forming? So whatever angle this we are going to form, we have to check theta. Theta is the inclination angle. Theta is what? Theta is the inclination angle. Now if theta will be less than this vertical angle, that is semi-vertical angle. If theta will be less than this semi-vertical angle, then whatever content will be coming, then it will be a real one. When theta will be equal to alpha, so that means inclination angle will be equal to alpha, then the plane touches the cone. Then only one point the plane will be touching the cone. Means if theta will be equal to the angle of inclination will be equal to alpha, that means semi-vertical angle, that means it is exactly touching the cone, no other thing. But if theta will be greater than alpha, means if theta part will be, means if it will be greater than alpha section, then it is going to be imaginary. This is only one case. This is only one case beta, when the plane is exactly going to touch the vertex. When the plane is exactly going to touch the vertex of both the cone. So this is the only case, but this we are not searching. This part we are not searching. Our search point is this section. Our search point is this one. Our area of concern is these planes and how these planes are exactly making angle with semi-vertical axis, and then how it is exactly forming different figures. Our area, search area is this one. So we are going to go there to understand. So first case is exactly about when the plane is exactly touching the vertex point. Now plane is touching the vertex point is a separate condition. Now we are going to go towards the most important one. If plane will not pass through the vertex, and now the plane is exactly going to cut the different section of the cones. If the plane is going to cut the different section of the cone, then what will happen? Now the first section cut. This PDF will be available to you. Once the class will be over, this PDF will be available to you. Inclination angle beta. Now look here. The inclination angle you see. With this you will be able to understand the plane, what the plane is making with the cone, that will become the inclination angle beta. That will become the inclination angle. That is what I am talking about. So now here you see that the inclination angle with the main line, that is, I told you now, for remembering, take this as the height of the cone. It will be you will be able to understand from this line, that is the axis line, if you will be taking it as, so this theta will become the inclination angle. From the main center line, if you are going to take this one, then theta will be coming as pi by 2 beta, pi by 2, 90 degree. Can you see this one, Saranya? Can you see this one beta? That from this center line, if this is exactly the plane, so this is exactly the plane. Now this plane is exactly like this, flat plane is exactly coming, and the center line is coming. So it is, they are both are perpendicular to each other beta. So theta, the inclination angle, is making pi by 2. So when such case will be there, then, so beta, this is not only, so we are talking about only one plane right now. So how many planes we can draw? We can draw many planes here. But all the planes, only one condition has to be there, and that is all the planes should go perpendicular to this line, axis line. So all the planes should go perpendicular to that axis line beta. Our work will be over and we will always get circles. So how many cut circles you can get? You can get many circles from this. Come on, quickly tell me, did you understood this part? Till theta will be equal to pi by 2. When the cut will be, theta will be equal to pi by 2, what type of figure you are going to get? What type of figure you are going to get? What answer you are going to get? What type of figure you are going to get? When theta will be pi by 2, what type of figure you are going to get? Come on, quickly tell me, what type of figure you are going to get when theta will be exactly pi by 2? Understood, Gautam? Just it has to be 90 degree. Just it has to be 90 degree with the main axis line. It has to be 90 degree. Just keep this in your concept. Yes, Saranya, it is going to be circle. It is going to be circle. That is what. Only one small part, and I want you all to be active and you have to ask many questions. Wherever it is blocking, immediately stop. Auntie, can you explain again? Yes, Pooja. Now look here, beta. Only one work, Pooja, and that work is we have to take cones, beta. We have to take cones and just understand like this. Once you are taking a cone like this, now from this cone, the main axis line, we are going to draw. So when we were in class 10th, we were calling it as height. So let us take it as height. Okay. Now what we are doing is, beta, one plane is there. This plane is cutting this one. So plane, 2-dimension plane, cut this. Like you take a scissor and you cut it. But when you are cutting it, beta, this inclination angle, means this line and this line is making 90 degree. So whenever this line will make 90 degree, beta, if you will open this cone now, you will get a circular base. If you will open this cone, you will get a circular base. Means here you will be getting a circle. Again with scissor, if you will be cutting this region, beta, you will again get a circle. With scissor, if you will be cutting it, you will get a circle. Again with scissor, if you will be cutting it, you will get a circle. That means what, beta? When theta will be making pi by 2 with this line, it will always make circular figures. It will always make circular figures. How many cuts you will get, that many circles you will be getting. Now understood? Come on, quickly tell me understood, so that we will go to the next point. Tell me fast. Understood this point? Understood, Pooja? Okay, we'll go to the next point. Today there will be an extensive class. Be ready with me, be ready to be with me, and please cooperate. Okay, now next important point is, as the content suggests that now we need another type of cutting. Understood everyone? Come on, quickly say auntie understood, move forward. Okay Aparna, everyone tell auntie move forward, we are understood this concept. Okay, now look here beta, again same cone representation is there, everything is same, but this time if you will see, you will see one small change beta, and that change is this angle is exactly more than 90 degree. You see here, when theta will be exactly, sorry, this theta will be exactly less than a, because you know that this part is exactly what, semi vertical angle. Now theta is exactly going to be greater than a semi vertical angle, but it is less than pi by 2. So we are going to take this section, we are going to take this part when the cut will be like this. Okay, when the cut will be like this, then we are checking one angle from this side. Okay, so now what we are checking here is that theta will be exactly coming here, theta will be whatever theta part is exactly coming here. This value means once theta lies between alpha to pi by 2. What is alpha? Alpha is the semi vertical angle, means it should be greater than alpha and less than pi by 2. Here it was exactly pi by 2. Since it was exactly pi by 2, we got a circle. For ellipse, you have to remember one thing, that it has to be between alpha to pi by 2. That's only one thing. You have to remember that, but not for this examination. For any competition or anywhere when they will be asking, you should be ready to answer that, okay, if I am getting an ellipse, means the inclination angle should be between alpha to pi by 2. Alpha is exactly what? Semi vertical angle. Okay, alpha is what? Semi vertical angle. So like this content, the moment you will be going, you will be telling it correct. Okay, so this is exactly going to make an ellipse. So always whenever, so if you are not remembering this also, whenever you will have a cut like this, you will always make an ellipse. You will always make an ellipse. Okay, you will always make an ellipse. Okay, theta will be taken from which side? Here if you are going to see, it is not clear. Here you are, if you will be checking this part, if you will see this section, they have not taken from this, so it is not coming 90 degree. Here you have to exactly draw this line. Once you will be drawing this line, you will be seeing that it is coming acute angle. It will be coming acute angle, it will not be coming, see, this part will be coming acute angle, and this angle will be exactly less than. And here the most important point is, we are going to take this part. This angle we are searching. Okay, so this section angle we are searching. Yes Saranya, this angle we are searching beta, because here if you will be taking this angle from this side, if I am taking angle here this side, but if you will be taking this angle also, just draw one line, one perpendicular, you draw one line like this. You will be seeing that all the angles are exactly less than. You will be, if when cut like this will be there, and this plane surface you are, because it is a plane, if 3D you are going to see, then it is exactly like plane will be coming like this, and here ellipse formation will be there. Now this line will be the vertical line, and this is the plane, this is the plane region. Okay, so now this axis is exactly, because here only you are going to get this part, from here only it is going to cut like this. Okay, from here you are going to cut like this. So take this angle, because this angle will be there, this angle will be there, this angle will be there. So that is what they are telling, that the inclination angle will lie between, the value of theta will be lying between 0 to pi by 2, means it will be acute. It will not be directly pi by 2. I hope now you have understood here. Now come on, quickly tell me, did you understood? Now this part you will cut, you will get a triangle, and from this the angle will be exactly less than, all angles will be exactly less than. Inclination angle will be less than, it will be going acute only beta, it will be going acute only. Doubt clear or not? You cut this part, you will be able to know. When you will be cutting this region, you will be able to know. Just cut this region, it will come like this. Understood Saru? Beta, just draw one line, draw another line, and then join like this. Whatever triangle, means whatever inclinations angles you will be getting, it is exactly in 2D we can draw like this, it will be easy to understand. So all will be exactly coming acute. So that's why we are saying that, okay, theta will be exactly greater than semi vertical angle, but it will be less than pi by 2. It will be less than pi by 2. It will be less than pi by 2. Yes, here also you can do. If you will take a plane now, you just take a scissor. Scissor will be acting as a plane. When you will be cutting this from the scissor part, if you will cutting like this now beta, it will be coming like this. For 2D it is difficult to explain this part. You are seeing only this dotted lines now. So whatever angle will be coming, it will be less than 90 degree beta. Whatever angle will be coming, it will be less than 90 degree. Okay, so here next part will be coming. Now here theta will be equal to here vertical angle, whatever vertical angle will be there, if that vertical angle will be that for parabola. Gautam ma'am, for the circle the theta value is taken from height, but for the ellipse y from cone slant height. See, look here, don't go there. You are going to check, you check all the inclination angles. You check all the inclination angles, each angle will be less than 90 degree. Each angle will be less than 90 degree. It will confuse you. It will confuse you to Vera level. So just go to, don't go there. You just see whatever concept you have understood, go stick to the same concept part, and you just check all the three angles. All the three angles you will be seeing that it will be less than 90 degree, but some of that angle will be coming as 180 degree. Okay, then it will help you better. It will help you, otherwise it will create a Vera level confusion. So just remember that cut. With that cut only the axis, the main angle will be exactly forming. So that part is exactly going to come. Shall we go for the next one? For understanding, we have to understand, stick to the main concept, otherwise it will confuse. Okay. Look here, if you are going to take the values, now look here beta, it is totally dependent upon what inclination angle you are forming for making an ellipse. Most important point here is, Sharanya, there will be a directrix line beta. The directrix line will be there. So we have to check many things there. The directrix line will be there for both the sides of the ellipse. Okay, for both the sides of the ellipse, one directrix line will be there. That I am going to teach in the second part beta. Just you have to remember one simple thing, that take a scissor, don't use the scissor like this. The moment you will use the scissor like this, you will be getting a circle, but the moment you will use the scissor like this, you will be getting an ellipse. I hope you might have understood this one. Easiest way to remember, like whenever you will cut the cone like this, keep on cutting the cone like this, you will keep on getting circles. Okay, but the moment you will incline the angle like this, so definitely when you are doing with the main axis, you will not be getting 90 degree. This is perpendicular one. From this is going to be perpendicular, but the moment you will cut like this, it will not be coming as perpendicular. And then if you will cut from this side, if you will cut from this side, again the same scenario will be there, because whenever we are going to take directrix line, you are knowing about now. So once we will go towards that, then many things will become clear beta. Okay, so till here everybody understood or not? First come on, quickly say me, till there you have understood this part or not? If we are going to check the ellipse section, just use this concept. Don't go here and there, it will confuse you to a different level. Just 90 degree and this will be less than 90 degree. Okay, just 90 degree and this will be less than 90 degree. Otherwise you will keep on having confusion, and second concept will again hang if you will not clear this case, section. So just remember that it will be theta value, means inclination angle will be exactly lying between alpha to pi by 2. In between this value has to be there. This concept has to be clear from this point. Okay, now next is, Saranya understood now? Now next important point is, when theta will be equal to pi by 2. When you are going to take theta, means main semi-vertical angle, whatever angle is coming, same we are exactly going to have that inclination angle, then 100% it is going to come as theta equal to pi by 2. Just for understanding we are creating this point. And now for hyperbola, case, you see that only one straight cut you are exactly, you see that line, whatever line we are following, same cut we are going to follow, and this is exactly coming as hyperbola. This is coming as hyperbola. This is coming as hyperbola. So these questions they are not asking. Just remember, for circle theta is equal to pi by 2. For ellipse it will lie between 0 to semi-vertical angle to pi by 2, and for this one it is exactly theta will be equal to alpha. So this is the case for This is the case for drawing for or finding the four different type of figures. Four different type of figures, that is circle, and then ellipse, and then parabola, and then hyperbola. Now shall we go? So now consider a double right circular. So this is exactly for your understanding I have typed, so that you, when you will be getting this PDF, you will be able to understand many things. Now the most important thing for understanding is, this is exactly called as directrix. This will be exactly what it is going to called as. This is a line perpendicular, and this is a fixed point. This is exactly a fixed point, and this is going to be the arbitrary point. Okay, Gautam, I am going to explain hyperbola. Hyperbola, no such case is there. If you will be seeing this hyperbola, one straight plane you take. One straight plane you take. Just 1 minute. How you are exactly going to cut here? Theta part will be independent or not. You only are going to just discuss this section. One cone you have taken here. One cone you have taken here. Okay. Now take a plane. Or now take a plane and just cut like this. So when you are cutting like this, what you are getting? You are exactly going to, once you will be cutting this part, you will be getting two hyperbolas. Okay. So two reasons you have to take. Two reasons you have to take for cut. Two reasons you have to take for cut. Okay. Then you will be getting a hyperbola. You will be getting which type of figure? You will be getting a hyperbola. Just see this part. You will be getting what? You will be getting a hyperbola. Here it will be more clear. You just say this. See this section. Understood now? Now we have seen hyperbola, we have seen parabola. Now we are going to go towards directrix, focus, and ellipse, and all that part we are going to discuss. Okay. Now general equation also we are going to see. The conic section general equation also we are going to see. But now first is, this is the directrix, the main line. The fixed line is called as the directrix line. The fixed point is called as the focus. The fixed point is called as the focus. The fixed line is called as the directrix line. Now what is exactly directrix line? What is focus? One by one we are going to see. So analytical definition of conic section is what? What is the analytical definition? They never ask this analytical definition. So we are not going to do that analytical definition. We are just going to understand it. Okay. So a conic section or a cone is the locus of a point P which moves in such a way that its distance from the fixed point always bear a constant ratio to its distance from a fixed line, all being in the same plane. Now if somebody can explain this line, then we have to go towards either a parabola, or we have to go towards an ellipse, or we have to go towards a hyperbola. Different type of figures we have to go toward. For circle I am going to check what is the definition of circle. Saranya, what is the definition of circle, and how can you relate the definition of circle with analytical definition of conic section? Anyone explain this connectivity? I'll explain the remaining part of it. Okay Rakshit, which part you want me to explain, Rakshit? See, look here, simple contents are there, Rakshit. Like if somebody will be telling you what is a conic section, then in what part you are going to explain a conic section? You just say that take a cone and cut it with scissor in different parts. Like if you will be, okay Rakshit, which part of the line you want me to repeat? I am just going to repeat that section just in the simplest way. Theta will be equal to pi by 2. Theta will be equal to pi by 2 is going to represent a circle. Okay, fine, no problem with that. If you are relating it with conic section, it is exactly going to be theta will be equal to pi by 2, Saranya. But what is the definition of circle? See, I am just going to connect the definition of circle with analytical definition of conic section. With analytical definition of conic section, what we have done. Rakshit, just एक बार बोलो कौन सा part repeat करना है बेटा, जल्दी से बताओ. ओके, जस्ट डेफिनेशन पार्ट्स ना, जस्ट एक बार मैं रिवाइज करती हूँ. फिर जस्ट अभी सर्कल से स्टार्ट ही किया है, एनालिटिकल डेफिनेशन के पार्ट से जस्ट रिवाइज स्टार्ट ही किया है. तो जस्ट एक क्वेश्चन मैंने पूछा है, बताओ क्वेश्चन डेफिनेशन. टेल द डेफिनेशन ऑफ दिस. व्हाट इज द डेफिनेशन ऑफ सर्कल? व्हेन यू एक्सप्लेन डिफाइन सर्कल, यू आर एग्जैक्टली यूजिंग लोकस. When you are defining circle, you are exactly using the word locus of a point, which is equidistance from the center. Always you use this word. What is a circle? Then you are saying that locus of a point which is equidistant from a center. Now locus of a point equidistant from the center. Okay, Saranya, just check that one beta. Theta equal to pi by 2 from cut point of conic section is damn correct. It is no problem in that, Saranya. But when somebody will be asking you the definition of circle, then you will be saying that, you know, auntie, the definition of circle is locus of a point equidistant from the center. Means if I am going to take one point and take the center point and I will allow the point to dance equidistance, I am going to take a circle. I am going to make a circle. A cone is cut in such a way that the plane passes through the center. Rakshit, is it enough for JEE? No, I am not going for JEE right now, but I am just explaining the concepts of conic section. I just started with, for CBSE, I am just started with the basic part, Rakshit. No other things I am discussing. I am just explaining the basic part of it. Okay. Yes, auntie, I didn't understood the question properly. Yes, can you explain the definition of circle? Then we will go towards the conic section and try and understand this part. JEE, it is not going to be enough. Never going to be enough for JEE. It is never going to be enough for JEE. First, what we are doing here is we are understanding the analytical definition of conic section, because when you will be going for directrix, when you will be going for focus, when you will be going for latus rectum, you should be knowing the basic point of it. Okay, Rakshit, you should be knowing the basic point of it. First ABCD and then for apple. Because once you know the basic points, beta, you will be able to handle all levels. But first, definition of circle, because we saw one thing in the definition of analytical definition of conic section. It is telling that a conic section or a conic is the locus of a point P. So definitely they are talking about locus of a point P. Right now, how many different type of figures you are having? Right now you are having 4 different types. What are the 4 different types? When we are going to talk about conics, we have circle, we have ellipse, we have parabola, we have hyperbola. So now the generalized statement it is giving. Yes. Okay, Rakshit. Bless me. I'll start that. First, CBSE syllabus is not finishing, Rakshit. Right now I'm just hanged with CBSE syllabus itself. Now look here, that means a conic section or a conic is the locus of a point P which moves in such a way that its distance from a fixed point. What is the fixed point we are talking about? Means a point P will be there. If different type of figure we are going to take, now I am just drawing my hand like this and I am drawing something. Is it exactly going to make a parabola? Okay, now whatever point will be there present on the that is on the surface of the parabola, from that fixed point and one directrix line I am going to draw. One fixed point and one directrix line I am going to draw, and I am going to move that point in such a way that it will always be equidistant from this fixed point, and this fixed point is nothing but the ellipse. This fixed point is nothing but the ellipse. Usually, you know how many ellipses are there? There are 4 ellipses. 2 ellipses are exactly the real one and 2 ellipses will be exactly the imaginary one. And because of 2 ellipses, we are going to get 2 directrix, beta. 2 real directrix because of 2 real ellipses. You have to remember this part. Totally, how many ellipses will be there? You can draw 4 ellipses. Okay, for different figures, you are exactly going to draw 4 ellipses, but 2 ellipses will be real and 2 ellipses will be imaginary. And if 2 real ellipses you are getting, then 2 different directrix you are going to get. You are seeing that for hyperbola and for ellipse you are getting 2 directrix, but for parabola you are drawing only 1. Okay, for parabola you are exactly drawing how many? You are exactly drawing only 1. There is a reason behind for drawing that one, and I think at the time when we will start parabola, you itself will say the answer why for parabola you are writing that one. Okay, 1 directrix you are going to write. Now shall we go back to the content, because first we have to understand the things like a story. Once we will understand the story, then we will be able to narrate the story in our own language. Mathematics is like that only, beta. So now most important thing is we have understood that it is a conic section or a conic is the locus of a point P. So that P point can move in such a way. So if I want that point to P to move, so this P point will move in such a way that it will always be equidistant from the fixed point. It will always be equidistant from the fixed point. Now the locus of a point which moves in such a way that its distance from a fixed point is always bear a constant ratio. It will always bear a constant ratio. So what type of what type of constant ratio? To its distance from a fixed line, all being in same plane. So that means we are going to understand that, okay, fine, one line is exactly going to draw, so we are going to remove this line. Now we are only going to take that fixed line, that is called as directrix. Directrix is the fixed line, okay, and then the fixed point is called as the focus one. Now we are exactly going to take that arbitrary point, okay, this point is considered as pxy. Now this will always bear whatever line you are going to write, pm, sorry, p already I have written, so this will become p, okay, this will become p and this will become m. So ps by pm, ps by pm, it will always bear a fixed ratio. It will always bear a fixed ratio. It will always bear a fixed ratio. So now what fixed ratio they are talking about? PS by PM will be exactly PS by PM. PS by PM will be equal to E. That fixed ratio they are talking about, PS by PM. So that is PS. This PS by PM will always have a fixed ratio. PS by PM will always have a fixed ratio. Okay. Spheres are the best. Ashutosh. Yeah, spheres are the best. Enjoy. Spheres are the best. Fine. Now, did you understood this one? The definition? Eccentricity is going to be 1. Super Saranya. So that is exactly talking about eccentricity, but PS by PM is exactly bearing a fixed ratio. For circle, what will be eccentricity, beta? For circle, what will be eccentricity, Saranya? For circle, what will be eccentricity? There is a time lag for both of that. Just 1 minute, Okay. So what will be eccentricity for parabola? What will be eccentricity for hyperbola? We are going to understand that eccentricity section. We will be drawing that figure also. We will be explaining everything. We will be understanding. Explaining. No, explanation work is my only. Okay. So did you understood the definition, analytical definition? Eccentricity means what, ma'am? Eccentricity definition is here. We are going to discuss eccentricity definition also. First we are going to go for, still I am in the analytical definition, because once my brain is stuck where, means till it will not be coming out, I will be stay there only. So what did you understood about definition, analytical definition? Ashutosh said eccentricity will be 0 for what? For circle or for ellipse? Ashutosh? For circle, eccentricity will be 0, Ashutosh. Yes, correct only. For parabola? For parabola? Yes. For parabola, eccentricity will be 1. Am I true? For ellipse? For ellipse, eccentricity will be less than 1. For hyperbola, eccentricity will be greater than 1. So we will be discussing about that, but first we will go to the definition, because still definition part is not clear. So I am going to go towards the definition. One fixed line is there. This is called as directrix. So this is the arbitrary point. It will move in such a way so that it will always bear a constant ratio. It will always bear a constant ratio. For parabola, it is going to be 1. Yes, absolute. Both of you are absolutely correct. So it will move in such a way so that it will always bear a constant ratio. Where are the rest of the children? If I told you that if you will have any doubt, we can discuss that one. So what is analytical definition? Means in this story, there is only 3 characters. You just understand what are the 3 main characters. Whatever you have studied in the beginning part from the class, don't think about that. The main characters are here. Directrix is the main character is there. Just understand that the figure what you are using, that is the second character, and eccentricity is the third character. So main basic 3 character, main hero heroine in this movie is exactly directrix and eccentricity part is there. So directrix, eccentricity, play with this. The ratio between them. The ratio between that is PS by PM equal to E. So this part you remember, PS by PM will be equal to E. PS by PM will be equal to E. Focus is there, not focus. Yes, Focus is there. Focus is going to be there. The fixed point, we are going to talk about focus only. Ratio I am talking about now. I'm talking about beta, the most important point here, that the main character eccentricity. After that only we are going to discuss. First we will talk about PS by PM equal to E, then we will settle eccentricity, and then we will remove eccentricity, and then we will talk about for conditions, and then we will go to general conic equation, and then we will remove that eccentricity part, and then we will go to another characters. So movie main hero heroine right now we are talking about. Now pxy is not eccentricity beta. Pxy is not eccentricity. If we will take that, means I am killed right now. Okay, some people will come and kill me. Just understand this part. So the fixed point is exactly called as focus. So we are going to use that fixed point as focus. So focus is there. Focus is there. Ratio is coming for eccentricity. Okay, I think I went blown away by the concept. So ratio is coming beta. This is exactly S. This is going to be focus. This is the arbitrary point pxy. Directrix is there. So PS by PM will be equal to fixed ratio is coming as eccentricity. And this S point is the fixed point. This is exactly going to become the focus. So changing the character of the movie, the main character of the movie is coming as directrix and focus, eccentricity, three main characters, and the figure itself, parabola, hyperbola, ellipse. So now one by one, just jokes apart, we are going to go to the serious part of it. So now what is directrix beta? The fixed straight line is called the directrix of the conic section. Focus, the fixed point. So now you are going to understand that what is the focus here. So now if this is the line is exactly called as directrix. Okay, the fixed line is called as directrix. Now from here, this point is exactly going to be the arbitrary point. I'm just using the word arbitrary for it. Now here, this is exactly going to be the focus one. Focus, 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 alpha beta. Take focus as alpha beta. You take like that. So the ratio. So the ratio between PS and PM will be coming as eccentricity. PS by PM will be equal to E beta. PS by PM will be equal to E. For your class right now, just stick to this part. Time to time we will change the concept. We will learn more. So from the beginners, if I want to understand PS by PM equal to E, and this is the analytical definition of conic section. The analytical definition of conic section says that PS by PM equal to E. Just understand till here, and then we will try to understand the next part of it. So now directrix is the fixed line. Generally, how many eccentricities will be there? Four will be there. How many? Four focuses. I said eccentricity 4 now. There will be 4 focus. 4 focus will be there. 2 real and 2 imaginary. And because 2 focus will be there, I talked about eccentricity. I went mental today. So now going back, grounded, the most important, I am repeating the content again, like 4 focus will be there. Since 4 focus will be there, 2 focus will be real, that is the fixed point. 2 focus will be real and 2 focus will be imaginary. Because 2 focus will be real, so 2 directrix will be there. Repeating the point again, because I think I said something wrong there. So I am repeating the part. There 4 focus will be there, 2 will be real, 2 will be imaginary. Since 2 real focus will be there, so 2 directrix will be coming. 2 directrix will be coming. And for parabola, how many directrix will be coming? Directrix will be coming only 1 there for parabola. Okay. Shall we go back to the next point? So now we are going to understand eccentricity. The constant ratio is called as eccentricity. We have already seen the axis, the straight line, which is exactly going to draw between the straight line. Now I am going to draw and explain. Otherwise I am going to, if I will see your comments, I will go somewhere again. Equation of this line will be ax plus by plus c equal to 0. Now this is the perpendicular one. Okay. Till here anything understood or it went out of your brain? In the story, what and all are the characters we have discussed? Eccentricity is there, which is the fixed ratio. Fixed point is focus. I think in the beginning part I talked eccentricity. So fixed point is called the focus, and then directrix line is exactly, the fixed line is called as the directrix line. The fixed line is called as the directrix line, and the ratio between PS by PM. So PS by PM is equal to E. PS by PM is exactly equal to E. So PS by PM will be equal to E. PS by PM will be equal to E. From there, first we are going to create the general formula. Okay, the general formula what we are going to generate from here is Directrix equation. Of Directrix is a line, so its equation can be written as ax plus by plus c equal to 0, and then focus point we will take it as alpha and beta. Okay, then ratio is coming between this. So one thing is there, we know the perpendicular distance formula. So first distance between this PS equal to E into PM, because we know that they bear a constant ratio. According to the definition, they bear a constant ratio. So PS by PM will be equal to E. So shifted this one this side. So now PS is what? PS is this one. So H minus alpha whole square plus K minus beta whole square will be equal to, this part is going to come distance formula. Now E, now we know this is perpendicular. To how to get the perpendicular distance, we know that this point is going to get substituted. It will become AH plus BK plus C by root under A square plus B square. Now what we are going to get? This root is there, so squaring both sides. Once we will square both sides, from here we will get the equation, conic section equation we are going to get is squaring both sides. The moment we are going to square both sides, H minus alpha whole square plus K minus beta whole square equal to E square. This part is exactly going to come as AH plus BK plus C whole square by A square plus B square, root will go. Now most important point here is that, see, if we will take the locus of this, because here in this point, if we are checking this part, this is the axis which is passing through the focus. Okay, so S point we are going to take it is the axis which is passing through the focus, and this is that P point. Now if we will take the locus of this P point, then we can take it as xy. If we will take the locus of this P point, we will take it as xy. Okay, so if we will take it as xy, then wherever h will be there, it will get converted as x and y. So the locus of h, the locus of h and k, since the locus is exactly h and k will be there, so we are exactly going to remove this part as x and y general. So this part will become x minus alpha whole square plus y minus beta whole square equal to E square. Now wherever h is there, it will become x. So ax plus by plus c by a square plus b square. Now here this part square is there. Now from this, if we will solve, we will get general equation of circle. Just one step I am doing. X square plus alpha square minus 2 this part plus y square plus beta square minus 2 beta y equal to eccentricity square. This is exactly going to a square x square plus b square y square plus c square plus 2 abxy plus 2 axc plus 2 byc by a square plus b square. So I'm just going to do one small step. First work is x square. This part is coming x square, this part is coming x square. So this part, when x will be multiplied, it is exactly going to come as a square plus b square x square. Now here alpha square, beta square, these two are constant. So alpha square plus beta square, and then it will be multiplied with a square plus b square, and then minus 2 alpha a square plus b square. This part is going to be x, and this part is minus 2 beta a square plus b square equal to, now it will be multiplied with eccentricity. So I'm just going to underline this part, whichever is going to be coming. So e square a square x square plus e square b square y square plus e square c square. So this equation only we are generalizing, and we are just converting some values, and we will be getting the equation of conics. So here e square, this part is coming, then it will come as 2ab e square xy plus 2ac e square x plus 2bc e square y. Now once you will shift this x square coefficient this side, so it will become x square, I'm just writing this as a square plus b square minus e square a square x square. Now this part we can take it as, this section we can take it as a x square. So this section we can take it as a, okay, this section we can take it as a, yes beta, okay, this section we can take it as a. Next one, this part is coming as alpha square, this is the constant region. I am going to take beta, y square is coming, so this is going to be 1 y square section I have missed, I guess I have missed. So minus 2 beta a square b square, y is there here, this is coming x, this is coming constant, then again a square plus b square y square. So now for y square plus a square plus b square, y square section is coming as minus e square b square y square, take this as b ax square plus by square, this section if you will take it as b. Now xy region, you have to check, this part is coming only xy, shift it this side, it is going to be minus, so take minus inside, 2 will be there, minus abe square xy, shall we take this one as h. So now this one will become 2h xy plus, now x region, this part is coming minus part. So now what we are going to do is, we will be writing 2 taking out x part. So here it is going to be minus alpha a square plus b square, and then from here x we are going to take out, there it will become minus 2 I have taken out, so it will become ac e square, x is there, so this part will become g 2gx. Okay, so final substitution of the values we are exactly doing. This is the main part, this is the nerve touching section. Okay, so now next is y part. So now 2 taken out, so once 2 is taken out, minus beta a square b square minus beta a square b square, it is b, it should not look like beta, okay, it is b, it should not look like beta. This is beta, this is beta. So now this part is exactly going to come as this section, once it will shift that side, so minus bc e square, and y will be there, so this part is going to come as 2fy, this will become f. And now the last part is constant section. Here constant section is e square c square, will shift that side, that is alpha square plus beta square into a square plus b square, here only, plus alpha square plus beta square a square plus b square multiple, and that part is coming as minus e square c square, capital C square. This part will be coming as constant c equal to, this part will become the equation of conics. So we just whatever coefficients are coming, we just converted that coefficients as, this part is taken as e, this part is taken as b, this part is taken as h, this part is taken as g, this part is taken as f, and this part, constant part, is taken as c. So this will become the equation of conics. Understood anything or went out? So we started with the constant ratio. Nothing we have done. Now I am going to summarize this part. First part, beginning section, I did a massive mistake. I am just cursing myself. I just talked about this eccentricity. This part is the focus. The fixed point is going to be the focus point. One thing you remember, again and again I am telling, S is exactly going to be the focus. I missed that word, huh? So directrix is there. So it is exactly bearing a constant ratio. PS by PM will be equal to E. E is the constant ratio. Fine. Okay, I am going to explain again. So according to the definition of beta analytical part, the definition says that ki whatever point will be there, that point will always make a constant ratio with that this directrix line and this constant point. Okay, so it will always be a constant ratio with that what you call directrix line, fixed line, and fixed point. Okay, this P point is always going to bear a constant ratio. So that constant ratio will come, PS by PM will be equal to E. So this constant ratio part we have written PS by PM equal to E. Okay, now once we have written PS by PM will be equal to E, then PS is what? Distance formula applied for this one. For distance formula applied for this one, what we have written, that H minus alpha whole square plus K minus beta whole square root under part will be there. And then this section, distance formula, perpendicular distance formula, you remember this formula, we always discuss this one, that if 2 and 3 will be there and this equation is coming as 4x plus 3y plus 7 will be equal to 0, then how to get the distance of this AB? So what formula we are writing? AB will be equal to, 2 will be written instead of x, 3 will be written instead of y. So 4 into 2 plus 3 into 3 plus 7 by coefficient this one 4 square plus 3 square root under. This was the way to find the distance. So same distance formula I have applied here. I just wrote here beta the same distance formula applied here, and then I squared both side. Once I squared both side, then only, see, by the definition itself I have touched. I didn't did anything on my own. I purely used the definition. And in the definition section only whatever was there I just used it. I just wrote that part, that root under this is exactly bearing a constant ratio. PS by PM will be equal to E. That part only I have written. Then distance formula applied, perpendicular, the line perpendicular. If I'll speak something, I'll say something wrong. So I'm just going to speak to the main point, a line which is exactly some distance away, perpendicular point, where locus means now locus you are asking. Locus of a point means you move that point in such a way, that it will always be coming constant. Locus is that point only. Means you take an arbitrary point and you let that point dance in such a way so that it will always be equidistant around you. What is this? Okay. Locus of a point means take that point and let that point go. It will always be maintaining a distance, equal distance. Okay, like that in definition of circle already we have seen. So specific definition it is not coming because in my brain now conic section is there. Suddenly you ask locus definition. Now squaring both side. So once you will be squaring both side, just open this by formula, and then x square coefficient I gathered one side. X square coefficient I gathered one side. X square coefficient I gathered one side. Y squared, see, I did nothing literally. After writing that part, I'm just saying that locus of HK. HK means HK was the point on the, HK was the arbitrary point which can move in the figure hk was the arbitrary point. In the parabola, whenever we are taking this point, so this arbitrary point will be pxy. So this point always bear a constant ratio with the fixed point that is called as focus and the directrix. Okay, it will bear a constant ratio. So since it is bearing a constant ratio, one thing here is that first I have written here h and k, Gautam. I think this point only going to create problem for you. I have written that h and k, but since hk is one specific point, hk is one specific point, you can take it as 1, 2. But when we are talking the general part, when we are talking the general part that let this point dance in the full figure, let this point go to all that, then we cannot use one point, because if here one point is 1, 2, then this point may be different. It can become 0, 2, whatever point means there are many points on the figure, no, on the curve, many points will be there. So when we use a generalized statement, then we cannot write that 1 or 2. We have to write xy. So I just generalized it. Understood? I just generalized it rather than writing h and k. First I have taken one specific point and then I use that word, okay, the locus of hk. Locus of hk means let that hk point to dance, means rather than fixing pxy, I allowed pxy to move in the entire figure. So when we are allowing pxy to move in the entire figure, then one work will be there. We cannot be taking it only as h and k. We have to take it as x and y, because once we are converting it into x and y, means we can take any value of x and y. We can take any value of x and y. I hope now you might have understood this point. Gautam understood this point. So we are going to, instead of taking h and k, I took the locus of it. Locus of it means now it is not stationary, it can move in the entire part. So since if it can move in the entire part, we cannot take 1, 2 as only one point. We are going to generalize it as x, y, and that's why wherever equation were there, wherever h and k was there, we converted it into the general form, and by just the moment we converted into the general form, we got the conic section equation, and this became the conic section equation. Ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. Now this will become the equation of the conics. Now here these are the coefficients. Now we have to allow this coefficient to dance. First important thing is the constant ratio, that is E, will be exactly different for different type of figures. For parabola, we have to check that eccentricity has to be 1. For parabola, eccentricity has to be 1. So once the parabola eccentricity has to be 1, that means PS by PM will be equal to E. PS by PM will be equal to E. But once we are going to talk about parabola beta, so eccentricity will become equal to 1. So PS will be equal to PM for parabola. PS will be equal to PM. Now parabola, other conditions are also there. In parabola, the other conditions will be this part h square, na, it will become equal to AB. H square will be equal to AB, this coefficient. So there is a condition for pair of straight line, that condition we are going to write about delta, that is ABC. That part also tomorrow class I am going to discuss. Okay, so that part also in tomorrow's class we are going to discuss. This time is going to be, so till here shall I keep, so that tomorrow I am going to discuss the remaining part of it. Till here, any doubts are there, quickly ask. One massive mistake I have done, that fixed point, I can see it, eccentricity, it is focus only. Okay, thank you Saru for immediately cutting it, otherwise I could have went to Vera level. Bye Saranya. Tomorrow we are going to talk about the pair of straight line equation, and then from there how circle, parabola, ellipse will be coming. Eccentricity will be equal to 1 for parabola. Good night Saranya. Eccentricity will be equal to 1 for parabola, 0 for circle. If eccentricity will become 0 for circle, you know what is the equation of circle? X minus h whole square plus y minus k whole square, and that will be equal to radius square. So now one small thing is there, PS by PM equal to E. When eccentricity will become 0, then directrix line equation will not be existing. PS will become equal to 0. PS will become equal to 0. All concepts understood na? Super beta. PS will become equal to 0, because for parabola eccentricity, for parabola eccentricity is coming as 1, for circle eccentricity is going to be 0. Once For circle, eccentricity is going to be 0, so PS will be equal to 0. PS will be equal to 0. And that is what the distance formula we were discussing about. Okay, and then ellipse will be exactly, eccentricity will be less than 1, and hyperbola eccentricity will be greater than 1. Tomorrow again one small intro I'll give, and then we will start from there. This PDF I am going to provide you now only. Okay, bye everyone, good night. Thank you Saru again. Everyone, good night.